So in today's video, we're going to go ahead and do a couple of examples of integration by u-substitution for definite integrals. And specifically, we're going to look at the two different ways in which we can use u-substitution for definite integrals when we kind of want to change the bounds of integration or when we want to back substitute. And so most of these examples are taken from USC Math, University of South Carolina Math. And so the first example over here, we're taking the definite integral from 0 to 1 of x over x squared plus 1 quantity squared dx. And so over here we have an x squared plus 1 in the denominator, and that entire quantity is being squared, and then we have an x in the numerator. And we see these kind of difference in powers, and so it may be helpful to define u to be equal to x squared plus 1, and then du is just going to be 2x dx, right? And so over here we have an x and we want a 2x, so we just have to put a 1/2 outside, and then we get this is the integral from 0 to 1 of 2x over x squared plus 1 squared, quantity squared, dx. So now we have the 2x dx, we have the x squared plus 1 in the denominator, so we have, this is ultimately going to be equal to 1/2 times the integral from 0 to 1 of du, right, because that's the 2x dx. This is 1 over x squared plus 1 we said is u, and when we square that, we just get 1 over u squared, which is just u to the negative 2. So u to the negative 2. And so this is going to be equal to what? So here we have the 1/2. We can just keep that outside. It doesn't really matter. U to the negative 2, when we take the integral of that, that's just going to become u to the negative 1 over negative 1, or we can even write this, if you would like, as negative 1 over 2u. And we're evaluating that from x is equal to 0 to x is equal to 1. So here what we can do is we can back substitute, right? And so if we back substitute, then we just have to change this u. We have to replace it with our definition. We have to describe it in terms of x again. So we can keep, we can keep these two bounds of integration the same, from x equals 1 to x equals, or from x equals 0 to x equals 1. We can keep these bounds of integration the same, but we just have to redescribe u in terms of x. Otherwise, if we, replace u equals 0, u equals 1, then it's not going to work, right? It's going to give us a different value. So let's just go ahead and back substitute. So that's 1 over 2 times, we said that u is equal to x squared plus 1, so we just have to resubstitute. And then we're evaluating this from x equals 0 to x equals 1. And so when we evaluate this at x equals 0, we get negative, or actually when we evaluate it at x equals 1 first, we get negative 1 over 4. Subtracting that from negative 1 over, when we evaluate this at 2, we get 1 over 2. So that becomes negative 1/4, and then plus 1/2. 1/2 is just 2 over 4, so 2 over 4 minus 1 over 4, that's just positive 1/4. If I didn't make any arithmetic errors, let me remove that box. Okay, so there we go. This is the first method. You can do it the other way if you would like, where you change u and you change the bounds of integrations, or you keep it in terms of u, and then you change the bounds of integrations and describe them in terms of u as well, so they both match. But we're going to do that for the next one over here. So here we have the definite integral from 0 to 1 of x over the square root of x plus 1 dx. So this is a little bit different. We have x plus 1 in the denominator, but we're taking the square root of that, and then we have x in the numerator. And so over here, we don't really have a difference in powers, but let's try to get rid of this x plus 1. We just kind of want that to be, something taken to the power of 1/2, right? Because then that'll make it a little bit easier to integrate. And so it may be helpful to say, let u be equal to x plus 1. And so now we can get another equation over here, and this is actually very similar to a problem we did before. Then we can ultimately end up with, if we want to solve for x in terms of u, we get x is equal to u minus 1. And then what is du by dx? Well, that's just going to be equal to, well, du by dx is just 1, and so du is equal to dx. So we don't really have to change anything there. And so now let's just go ahead and substitute. So 0 to 1, this is the integral from 0 to 1. X, we said, is u minus 1. And the square root of x plus 1, we said x plus 1 is u. That's just going to be u to the 1/2 down here. Dx is equal to du, so that stays the same. But now we kind of want to change the bounds of integration, because here we're saying x is equal to 0, here we're saying x is equal to 1. But let's see what happens to u when x is equal to 0. So we know that u is basically just a function of x, right? U of x is equal to x plus 1. Well, what is u of 0? What happens to u when x is equal to 0? Well, u is just 1. And same thing, what happens to u when x is equal to 1? Well, u is just 2. So this becomes now the integral from u is equal to 1 to u is equal to 2 of u minus 1 times u to the negative 1/2, I just brought that up, du. And so now we can just continue and evaluate this like we would any other normal integral. We can expand this out, so this is the integral from 1 to 2 of u to the 1/2 minus u to the negative 1/2 du, and then you would just continue evaluating it as you would any other definite integral, describing it in terms of u. Evaluate this from u equals 2 to u equals 1. And so here what we did is we changed these bounds of integration. They were originally in terms of x, but then when we made our u substitution, we also substituted, or not really substituted, but kind of changed the bounds of integration. They used to be in terms of x, we switched them, we turned them in terms of u, and then we just proceeded like that. And so that's how you would evaluate this integral. Or you could do the other way, where you would integrate it in terms of x and then keep the bounds of integration in terms of x, and then finally you would kind of back substitute like we did in this previous example, where you back substitute, you redescribe it in terms of x, and then you keep the bounds of integration as well. So one thing that you really have to keep in mind when you're using u-substitution for definite integrals is that the bounds of integration, the variable that the bounds of integration are written in terms of, has to match that of the antiderivative.